Hi, Callie. Here is the first kind of problem that you missed on the exam. You have the equation x squared minus 7x equals negative 14, and you're to use the quadratic formula. And in the quadratic formula, you need to know what a, b, and c are. So they're the coefficients of the terms in your original equation that you're given. So a is the coefficient in front of x squared, b is negative 7, and c, you have to rewrite this equation before you can get c. You have to bring the 14 over and have the equation in standard form so that you have all of your x's on the left and 0 on the right. So you add 14 to both sides. So that means that your c is going to equal 14. Alright, so now that we have a, b, and c, we can plug into the quadratic formula. So we get x equals negative b is negative 7, plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is 14, over 2a, which is just 2. Okay, and then when you figure out what is under the radical sign, first of all, your negative 7 becomes a positive 7. And then 7 squared is 49. 4 times 14 is 56, so you have 49 minus 56. Over 2. And so that's going to give you 7 plus or minus the square root of 7. All of that over 2. But it's not 7, it's negative 7. And that's important because the negative inside of a radical needs to be gotten rid of. So you can rewrite that by pulling out an I, and that takes care of the negative sign inside the radical. So I means imaginary. There is no real solution to the square root of a negative number, and that's why we have imaginary numbers. So you end up with a complex expression, 7 plus or minus I square root of 2. And let me erase that line I just made. So the solution set is 7 plus I squared root of 7 over 2 and 7 minus I squared root of 7 over 2. Your answer was negative 7 comma negative 7. So let me know if you have any questions about this. In number 2, you're to solve using the square root property. In the square root property, you need a term with x in it on the left, for instance, x squared on the left, and a term of numbers on the right. So all of your x terms need to be on your left, and all of your regular terms need to be on your right. Let's start by getting that. We have 11x squared, but negative 125 does not have any x's in it, so we add it to both sides, and we get 2750, because 2625 plus 125 is 2750. Alright, but we need x squared by itself. We need a perfect square that is squared on the left. 11 gets in our way, so we're going to divide both sides by 11. And that gives us x squared equals 250. So now we can use the square root property. The square root property says you can take the square of both sides of an equation and still have an equivalent equation. The reason we want to do that is because our job is to solve for x. That means we need x to equal a number. So when we take the square root of both sides, we have to be sure to add and subtract on the right. So x squared has two solutions. One is plus, or the square root of x squared. One is plus the square root of 250, and the other is minus the square root of 250. Okay, key principle here. The square root of a square is simply itself. So x squared, the square root and the square cancel each other, and you're left with x. On the right, you need a perfect square in order to solve this. And one thing I like to do is if I see a 25, I know that 25 is a perfect square, so I'm going to have the 25, and 250 divided by 25 is 10. So I have 25, which is a perfect square, times 10, which is not. So that means that I can pull out, well, let me do it one more step. The 25 and the 10 can be handled with two separate radicals, and 25 is the same thing as 5 squared. And so the square root of a square is itself, so we have plus or minus 5 times the square root of 10. So that's your answer. X equals plus or minus 5 square root of 10, and you would write that 5 square root of 10 and negative 5 square root of 10. You answered 25 and 25. Complete the trinomial so that it is the perfect square. Then factor the trinomial. On this problem, you found the numbers you needed to find, but you did not apply them correctly. So this is one of those problems where you half it and square it. So we take half of 22 and we get 11. We square 11 and we get 121. And 121 is the number that we are going to add to r squared plus 22r to get a perfect square trinomial. So the squared version goes here, the squared version, and you got that number correctly. And then you have to factor that trinomial, so it's going, the factorization of a perfect square trinomial looks like this, where you have to find the binomial that goes inside the parentheses. So all you have to do is write r squared, r, not r squared, and then all you have to do is write the half it number. Okay, and then what do you put in the middle? Do you put a plus or minus? You put whatever you see here. So that goes there. And that's the factorization. That's all there is to it, and then you're done. So your answer to part B, to do the factorization, you answered 11 instead of r plus 11 parentheses squared. Number 4, Catrina and Tom are going to buy a rug for a room that is 20 by 15 feet. They want to leave an even strip of flooring uncovered around the edges of the room. How wide a strip will they need if the area of the rug is 234 square feet? So the first thing you want to do is draw a picture. So here's the picture. The outer rectangle is the room, and the inner rectangle is the floor. And we are told, the rug, and then we are told the rug is 234 square feet. The room, we are told, is 20 feet long and 15 feet wide. And we are to find how wide this little strip is of flooring that is between the room's edge, or the walls, and the new rug. So we're going, and the strip is the same width all around, so we're going to call it a width of S for strip. Okay, and then we are going to find the width of that strip. Alright, so what are the length and width of the rug. We aren't told what they are, but we do know that they are smaller than the room length and width. So let's look at the room length. If we take 20 and then this is the whole length of 20 here. And then we subtract this strip here and this strip here. So those little areas right here and here are also S long, which we don't know what S is. So what is in the middle is 20 feet minus S for this S, and then minus another S for the other S. And that gives you the length of the rug. See, it just is part of the length of the overall room. So if we call the length of the rug L, then we have this formula. L equals 20 feet minus S minus S. We can rewrite that to say L equals 20 minus 2S. If we use the same reasoning for width, we will find that width equals the width of the room, which is 15 feet, minus 2S. Okay? And then we know that the width of the rug, which is 15 minus 2S, times the length of the rug, which is 20 minus 2S, gives us the area of the rug. So the formula we are using is length times width equals area. And since we know the area of the rug, we can substitute for the length, it's 20 minus 2S. That is what we saw the length to be. And the width is 15 minus 2S, the width of the rug, just as we got over here. And so that all of that is going to equal the area of the rug, which we are told is 234 square feet. That is how you set up the problem. And now you have to solve the problem. So we use FOIL to say 20 times 15, you'll find that's equal to 300. And then that's the first terms, 20 times 15. Then we do the outer terms, 20 times 2S. That's going to be a minus, because the 2S is minus. So we get minus 40S. And then we do the inner terms, negative 2S times 15, and that gives us minus 30S. And then we do the last terms, minus 2S and times minus 2S, which gives us a positive 4S squared. Okay, let's combine like terms and put the left side in descending power order. So we have 4S squared minus 70S plus 300. So that's the left side of the equation. The right side of the equation is 234. Let's go ahead and bring that over by subtracting 234 from both sides so that we can have an equation that equals 0. So simplifying it once more, 4S squared minus 70S minus, and then we get 66. 300 minus 234, actually that's plus. 300 minus 234 equals 66, and that equals 0. Okay, it looks like each of those terms are divisible by 2, so we're going to pull out a 2 as a common factor, which means we're dividing everything by 2. And we get 2S squared minus 35S plus 33 equals, and 0 over 2 is 0. Okay, I've made all that a little smaller so we have room to work. I'm going to divide both sides by 2, and that cancels this out, and 0 divided by 2 is still 0. So I get 2s squared minus 35s plus 33 equals 0. Now I can use the quadratic formula or I can factor, but since we're studying the quadratic formula, let's go ahead and do that. So the quadratic formula says that s is going to be negative b plus or minus the square root of b squared minus 4ac over 2a. So b is 35, so s equals negative b. B is negative 35. S equals negative b, which is negative of negative 35, plus or minus the square root of negative 35 squared minus 4 times a times c, all of that over 2a. Alright, so you work all of that out. All of this equals 961. The square root of 961 is 31. So you have two cases. S equals, and then you add 35 and 31 to get 66 over 4. Or S equals, and then you subtract them and you get 4 over 4, or 1. Now 66 over 4 is going to be 33 over 2, which is 16 and a half. Okay, look at your picture and you see that S is this distance here. If S is 16 and a half, that means this width between the carpet and the floor is longer than the width of the floor itself, and that's impossible. So we can disregard this solution because it doesn't work, and that leaves us with our solution, which is that S equals 1 foot. Your answer was 3. In number 5, you're to use the square root property to solve the equation 6t squared minus 48 equals 0. The square root property simply says that if you have something squared equal to a number, you can take the square root of both sides to solve it. In this case, we have 6t squared minus a number equals 0. Notice we don't have a t term, we just have a t squared term. So let's get the t squared by itself by adding 48 to both sides, and we have 6t squared equals 48. Now 6 is not a perfect square, so we don't have the left side as something squared yet, so we have to divide both sides by 6, and that gives us t squared equals 48 divided by 6 is 8. So now we can take the square root of both sides, but we have to do plus or minus the square root of the right side. Square root of a square is itself, so we have t because the square root and the square cancel. And then we have plus or minus, and then under the radical we want to see if we have any perfect square factors. 8 is 4 times 2, and 4 is a perfect square. So we can say this is the same thing as, well, 4 is 2 squared, square root of 2, and so that's going to give us plus or minus. The square root of 2 squared is 2, and we still have square root of 2 left over. So t is either equal to 2 square root of 2 or t equals negative 2 square root of 2. You answered 1 and 2. An object is launched vertically upward from the ground. Its distance in feet from the ground after t seconds is d of t equals negative 16t squared plus 208t. After how many seconds would the ball be a distance of 500 feet from the ground? So someone's throwing a ball up in the air and it's coming down. And you want to know at what time will the ball reach 550 feet. So it's going to reach 550 feet in 2 times. The first one is on its way up and the second one is on its way down. The only exception to that is if 550 feet is exactly how high it goes, and then there will only be one solution. But you are going to look for 2 solutions to see what time it is that the ball is 500 feet from the ground. And you're told that that height or distance from the ground is given by the formula -16 times squared plus 208 times time. So all we have to do is plug in 550 for the distance d of t. That's a function, so you can just call it d, distance. So we're going to plug in 550 feet and solve the equation. So 550, and I didn't write that right, 550 equals -16t squared plus 208t. So let's get everything on the left. We're going to add 16t squared to both sides, subtract 208t, and then we have our 550 already on the left. All of that is equal to 0. And we see that all of those numbers are even. They're not going to be divisible by 4, but they are going to be divisible by 2. So we're going to pull a 2 out and then divide each term by 2. And that gives us 2 times 8t squared minus 104t plus 275 equals 0. And then when you divide both sides by 2, you still get 0 on the right, so I'm just going to scratch out that 2. Now we have an equation, 8t squared minus 104t plus 275 equals 0, and we need to solve it. We can solve it either using factoring, but we probably won't be able to do that because if your answer is a decimal, factoring won't help you. Or using the square root property, which we could do fairly easily. In fact, since the middle term is even, that's when you know the square root property might be easier than the quadratic equation. And it's good practice anyway, so let's set it up to use the square root property. Okay, we're going to come over on the right, and I'll start writing in white to distinguish what we've already written. What we need is we need all of our t terms on the left, so we're going to put 8t squared minus 104t, and then we're going to subtract 275 from both sides so that we can have our t terms equal to a number. Now before we can use the square root property, our lead term has to not have a coefficient other than 1 in front of it. In other words, how do we make this 8 go away? Well, it just so happens that we can divide everything by 8, and we are left with t squared minus 13t equals. And then I'm going to leave the 275 over 8 because it doesn't come out a whole number yet, but it will. Okay, so we need to know what number we need to add to both sides to get a perfect square trinomial on the left. So we half it and square it. So we're going to half it by saying 13. Half of 13 is 13 halves. And then when you square 13 halves, you get 169 over 4. So we're going to add 169 over 4 to both sides. Now that's not as hard as you think it is. On the left you already know what your factorization is going to be. It's going to be t, and then it's going to be minus like that, and then it's going to be the half it, which is 13 halves squared. So that's your binomial. You have a squared term on the left now, which is what you wanted. Equals. Okay, let's come over to the right, and we'll work in red, and we're going to add negative 275 eighths to 169 fourths. So we need a common denominator. Let's multiply the second term by 2 over 2, and we get negative 275 over 8 plus 338 over 8. And that's going to equal 63 over 8. So what we've just done is we've just found that the right side of the equation, which was negative 275 over 8 plus 169 over 4, works out to be 63 over 8. That didn't look very good. Let me fix that 6. Okay, so now we have to take the square root of both sides. So I'm going to clean up my screen a little by shrinking everything and moving it down. But let's rewrite our last step. We had t minus 13 halves squared equals, and I'm going to give myself a little room on the right, 63 over 8. Now we can apply the square root property, which says we can take the square root of both sides and still have an equivalent equation as long as we add and subtract the right side. When we do that, our left side simply becomes t minus 13 over 2, and our right side is plus or minus square root of 63 over square root of 8. An object is launched vertically upward from the ground. Its distance in feet from the ground after t seconds is d of t equals negative 16t squared plus 208t. After how many seconds will the ball be a distance of 500 feet from the ground? This is a function called d of t, but you could really just write d because d represents the distance from the ground. So what we're trying to find is a ball is thrown upward and comes back down, and at some point it reaches 550 feet. It reaches it on its way up, and it reaches it again on its way down. So there are two times, the time where it reaches 550 on the way up and the time where it reaches it again on the way down. So we're going to have two solutions to this problem, unless 550 turns out to be the very top of the propulsion, so that the ball reaches the apex at 550 feet. But we're going to work it and see where we end up. All we have to do now is substitute for height 550 feet to set up the problem. 550 equals negative 16t squared plus 208t. So let's bring everything over to the left and put it in descending power order. And we're going to solve this using the quadratic equation. Now when I look at this, I can see that everything is divisible by 2, so let's go ahead and take 2 out of everything. And so we get 8t squared minus 104t plus 275, and then 0 divided by 2 is still 0. Using the quadratic equation, we see that t is negative b, which is negative 104, so it's negative of negative 104 plus or minus the square root of b, negative 104, squared minus 4 times a, which is 8 times c, which is 275. All of that over 2a, which is 2 times 8. Alright, let's simplify that. And we end up with a square root of 2016 we have to simplify in order to find the answer. And the square root of 2016 is about 44.9, so we have 104 plus or minus 44.9 over 16. So when we punch all of that out on the calculator, we see that t is either equal to 9.3 seconds or 3.7 seconds. So it rises to 550 in 3.7 seconds and falls in 9.3 seconds. This problem was a little harder to manipulate than the one on your exam. The one on your exam had whole number answers. So that'll be a lot easier. So if you can do this problem, you should easily be able to do the one you encounter on the exam. Several hours after the departure, the two ships described in the picture are 170 miles apart. If the ship traveling south went 70 miles farther than the other one, how many miles did they each travel? So let's say the ship traveling west goes x miles. The ship traveling south goes x plus 70 miles. The Pythagorean theorem says if you have a right triangle, then you can square each of the legs, add them together, and then they should equal the square of the hypotenuse. In other words, a squared plus b squared equals c squared. So in this case, one of the legs is x, the other leg is x plus 70. So let's square each of those and add them, and they should equal 170 squared, which is the length of the hypotenuse. So we've set up the problem. All we have to do now is simplify. So the parentheses here goes out. If you FOIL it, you'll get x squared plus 70x plus 70x plus 70 squared. So we're going to do x squared plus, and then 70x plus 70x is 140x plus 70 squared. So if you do that yourself, then you will see that it works out to that. And all of that is going to equal 170 squared. That gives us 2x squared plus 140x plus, and then 70 squared is 4,900 equals 28,900. We can see right away that everything's even, so let's divide it all by 2. Because we prefer working with smaller numbers. X squared plus 70x plus 2450 equals 14,450. So we bring the 14,450 over, and then 2450 minus 14,450 equals negative 12,000. So all of that is equal to 0. And now we can do the quadratic formula to solve for this. Or you can do factoring, but since you're doing big numbers, it would be better to do the quadratic formula. The quadratic formula says that x is going to equal negative b plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is negative 12,000, all of that over 2 times a, which is 1. Okay, so let's simplify that. And so we get that x is negative 70, and then 70 squared plus 48,000 gives you 52,900, Square root of that is 230. So x is either equal to negative 70 plus 230 over 2 or negative 70 minus 230 over 2. If you look at the negative 70 minus 230, you can see that you're going to subtract a negative from a negative, and that's going to give you a negative. But x was the distance, and distances cannot be negative, so we can disregard the negative solution. So our correct solution is x equals negative 70 plus 230 over 2, which is going to be 80 feet. So the first distance is 80, the one going west, and the one going south is 80 plus 70, or 150. So the distances are 80 going west and 150 going south. Let's check our work. We use the Pythagorean theorem again. The Pythagorean theorem says a leg squared plus a leg squared equals a hypotenuse squared. So in this case, going west is 80 miles. So we square 80, and then going south is 150. So we square that. When I said plus, it should be equal. So it should equal 170 miles squared. So we get 6,400 plus 2,500 equals 289,000. And on the left, those two numbers add up to 289,000. So we've just checked that our work is correct, and our answers are 80 miles and 150 miles. Your answer is something like 6 and 8 miles. Okay, this is a lot, so I'm going to go ahead and save it and process it and send it to you so you can get to work, and then I'll probably do the rest of it tomorrow.